A lonely speck drifted through the void, colder than thought itself, older than our own sun. For months, it had been nothing more than a whisper on astronomers' charts, a faint point of light racing inward from the direction of Pegasus. When the James Webb Space Telescope finally turned its golden mirrors toward that point, humanity was about to see something it had never seen before. The first real image of 3I/ATLAS. When the signal came in, the data streams pouring from the telescope slowed to a deliberate crawl, as though the universe itself were holding its breath. At first, it looked ordinary, a small cometary blur, a faint tail of dust stretching behind. But then the algorithms began to sharpen the composite pixel by pixel, and the image resolved into something startlingly alive. Its coma glowed not with the green hue of ordinary comets rich in cyanide or diatomic carbon, but with a deep infrared signature that suggested frozen carbon dioxide, far more of it than any comet from our system had ever shown. That single difference told scientists that 3I/ATLAS had been born around another star entirely, perhaps in a system colder, darker, and more remote than our own. For the first time in history, we were looking directly at matter forged beneath a different sun. The discovery itself had come months earlier. On July 1st, 2025, a small automated telescope in Chile belonging to the Asteroid Terrestrial Impact Last Alert System, ATLAS, picked up a faint, fast-moving point of light. Its motion didn't fit the pattern of any known asteroid or comet. When orbital calculations were run, the numbers refused to close. The trajectory wasn't bound to the sun. It was open-ended, a one-way curve from the depths of interstellar space. Astronomers at the University of Hawaii were the first to suggest what it was: the third interstellar object ever recorded. They gave it a formal designation, 3I/ATLAS, and a nickname that would soon sweep through every scientific journal on Earth: the Visitor. It moved fast, more than 200,000 kilometers per hour, screaming through the darkness like a stone thrown across a cosmic pond. Within weeks, every major observatory had turned to catch a glimpse before it was gone. But one instrument above all others was built for this kind of work: the James Webb Space Telescope. Its mirrors, cooled and polished to perfection, were capable of catching the faintest photons from the coldest bodies. On August 6, 2025, Webb locked onto the coordinates, its instruments calibrated for a target no one had ever dared to imagine. For hours, the telescope's near-infrared spectrograph collected light, building an image layer by layer. Scientists at NASA's Goddard Space Flight Center waited as data streamed down from Lagrange Point 2, almost a million miles from Earth. When the raw images began to appear, even the most seasoned astronomers went silent. What Webb captured wasn't just another comet. The structure of 3I/ATLAS was strange. Its coma appeared asymmetrical, its tail behaving like a ribbon twisting under invisible currents. The spectrometer revealed that carbon dioxide was outgassing far more strongly than water, a ratio unlike any comet ever seen in the solar system. That composition implied formation in an environment too cold for water ice to dominate, perhaps far beyond the frost line of its native system. Some compared it to finding a snowball made entirely of dry ice drifting through the warmth of a bonfire. Across the scientific world, comparisons began. Oumuamua had baffled researchers by accelerating without a visible tail, prompting speculation that it might be a fragment of a larger body, even a relic of alien technology. Borisov, in contrast, had looked more like a standard comet, albeit one of interstellar origin. But 3I/ATLAS stood somewhere between them, visibly comet-like yet chemically foreign, active yet oddly stable, a fusion of the familiar and the unknowable. At NASA's Jet Propulsion Laboratory, orbital analysts traced its inbound path. The trajectory suggested it came from the direction of the Lyra constellation, though pinning down a precise origin star was nearly impossible. Over millions of years, gravitational nudges from passing stars could have altered its course beyond recognition. Somewhere, far from here, a collision or planetary migration might have flung it free, setting it on a long, slow exile that finally intersected our system. As the object approached perihelion, its closest point to the Sun, telescopes across Earth followed in unison. The Hubble Space Telescope captured visible light data, while the upcoming SPHEREX mission prepared to scan for chemical fingerprints. For once, rival institutions coordinated instead of competing. This was history, and every scientist knew it. Webb's image became the centerpiece of that effort. In false color, the object appeared as a glowing coal against the blackness, a heart of solid ice shedding gases into space. The contours of its nucleus, roughly 2 kilometers across, hinted at a rough, irregular shape. In the surrounding halo, spectral analysis picked out traces of exotic compounds, carbon monoxide, methanol, and complex organics. Some of these molecules were precursors to amino acids, the chemical seeds of life. That realization sent a quiet shiver through the team. If 3I/ATLAS carried organics from another star system, it meant the building blocks of biology were not unique to Earth's corner of the galaxy. They might be everywhere, scattered like spores between the stars. Each interstellar comet could be a courier of chemistry, drifting across the Milky Way, spreading the potential for life in places we would never see. For the public, Webb's image was a revelation. Released by NASA with minimal fanfare, it spread across social media within hours. The photograph wasn't flashy, a red-tinged smudge surrounded by an amber halo, but it carried a weight that words could not capture. Humanity was seeing something that had never belonged to our sun, a relic of another dawn. In classrooms, scientists compared it to a cosmic message in a bottle, carried across light years, uncorked by our technology at the perfect moment. Behind the scenes, astronomers debated furiously. Some argued that the high carbon dioxide content meant 3I/ATLAS had formed closer to its original star, perhaps where CO2 ice could condense on silicate grains. Others thought it came from a region beyond a giant planet's orbit, ejected during the system's chaotic youth. A few entertained stranger possibilities, that it might be a fragment of a larger body destroyed in a stellar encounter, or a remnant of a protoplanet stripped of its atmosphere. Each scenario painted a different picture of the world that had given it birth. In a late-night briefing at the Space Telescope Science Institute, project scientist Dr. Mara Levin described what the team felt: awe mixed with urgency. "This is a once-in-a-lifetime visitor," she said. "Once it's gone forever." Every photon counts. Her voice carried the weight of realization that 3I/ATLAS was not just another data point, but a piece of cosmic history passing before human eyes. For weeks, the telescope followed its fading trail. As it receded from the sun, the outgassing slowed, the coma dimmed, and the tail began to collapse back into darkness. But even as it disappeared, the data it left behind transformed our understanding of how star systems form and evolve. For the first time, astronomers could compare 3 distinct interstellar objects, Oumuamua, Borisov, and ATLAS, and begin to see patterns. All 3 were different, yet each carried clues about the diversity of planetary systems scattered across the galaxy. The implications went beyond chemistry. If small bodies like these were common, drifting endlessly between stars, then the material of worlds was constantly being exchanged across the Milky Way. Dust from one system could seed another. Life, if it ever arose somewhere else, might not be entirely isolated. The universe might be sharing itself, molecule by molecule, across distances too vast for our imagination. As 3I/ATLAS passed the orbit of Mars, it briefly brightened again, catching sunlight at a sharp angle. The image Webb took at that moment would become the defining frame, the first real image in every sense. It showed the nucleus sharply silhouetted against a faint fan of vapor. No longer a blur, it was a solid, tangible object, proof that we had touched another solar system with our gaze. Scientists compared that image with radar models and light curves from ground-based telescopes. The shape appeared lumpy, perhaps contact binary, 2 smaller bodies fused together. That could explain the odd asymmetry of its coma and the uneven outgassing. It wasn't a single, pristine object, but a survivor of collisions, carrying the scars of its birth. News outlets tried to simplify it. James Webb captures alien comet, one headline read, while another called it a messenger from another sun. Yet the reality was more profound than any headline could contain. 3I/ATLAS wasn't alien in the cinematic sense. It was natural, silent, indifferent. But its existence reminded us that the cosmos is not isolated into neat compartments. We live in an ocean of exchange, where even the debris of other worlds can find its way to our doorstep. By late September, the comet had faded beyond Webb's range. The team released a final composite, hundreds of frames stacked into a single glowing portrait. In it, the comet looked like a scarlet ember adrift in blackness, its light smeared slightly by motion, as if time itself were reluctant to let it go. That image joined the ranks of humanity's great cosmic portraits, alongside Hubble's Deep Field, the Pillars of Creation, and the first view of Earthrise from the Moon. Still, for all the data collected, one question remained unanswered. Where had it come from? Orbital reconstruction suggested a possible path originating near the star Vega, about 25 light-years away, but the uncertainty was enormous. Over millions of years, even tiny gravitational tugs from passing stars could have altered its course beyond recognition. In truth, its home was gone, erased by time. What mattered was that it had reached us. In the months that followed, mission planners at NASA and ESA began to discuss the impossible. Could a future spacecraft intercept an interstellar object like this? Studies suggested that with enough preparation, a next-generation probe launched at extraordinary speed might one day catch such a visitor. Engineers dreamed of a future mission capable of meeting a traveler like Atlas head-on, collecting samples and uncovering its secrets up close. But for now, Webb's image would have to be enough. It was a reminder of what human curiosity could accomplish. A telescope stationed 1 million miles from Earth, built from gold and precision, capturing light that had traveled for tens of thousands of years, all to reveal a speck of ice from another world. As the data analysis continued, one curious result emerged. The isotopic ratios in the emitted gases suggested a slight enrichment in heavy carbon, an indicator that the comet's parent system might have formed in a region of the galaxy richer in older stellar debris. In other words, 3I/ATLAS could have come from an ancient star system, one forged in the aftermath of multiple supernovae. If so, the molecules within it carried the ashes of long-dead stars, condensed into new worlds, then ejected once more into the endless cycle of cosmic rebirth. For the scientists who had spent their lives chasing faint light, that realization was almost spiritual. It meant that somewhere out there, another world's history had brushed against ours, leaving a fingerprint of stardust we could measure. It was a quiet kind of connection, not communication, not contact, but kinship in the shared matter of creation. When asked what it felt like to see the image for the first time, Dr. Levin paused. "It was humbling," she said softly. "For a moment, you forget about the equations, the calibrations, the deadlines. You're just looking at something that's been traveling for millions of years, waiting for someone to notice." Outside the telescope's orbit, 3I/ATLAS continued on its way, fading into the black. In a few months, it would slip beyond Neptune's reach and never return. The light reflecting from its surface would keep traveling, spreading thinner and thinner, until even the most powerful telescopes could no longer find it. But the memory of that faint glow and the data it carried would remain. In the grand story of exploration, this moment would be remembered as one of the quiet revolutions. No explosions, no roaring engines, just a telescope, a patch of sky, and a whisper of light from another world. The James Webb Space Telescope had done what humanity had dreamed of for centuries. It had looked beyond our solar system and brought back proof that we are not alone in the materials that shape our existence. Somewhere, a scientist might still be scrolling through those raw frames, staring at that blurred speck, wondering if, perhaps, another civilization once looked at a similar comet leaving their skies and thought the same thing, that the universe was full of travelers, each carrying the story of where they came from. In the end, 3I/ATLAS gave us more than data. It gave us perspective. It reminded us that every atom on Earth, every fragment of stone and strand of DNA was born in stars just like the one that sent this comet our way. We are all debris of creation, drifting, searching, reflecting the light of whatever star happens to find us. As the final frame from Webb settled on screens across the world, the faint red dot lingered at the edge of vision. A visitor on its way back to eternity, and in that moment, humanity looked up, not just in curiosity, but in recognition. Because somewhere, out there in the deep dark, something once looked back. And we finally saw it. The data didn't stop speaking once the comet was gone. As researchers at the Space Telescope Science Institute continued sifting through terabytes of infrared spectra, they began to realize that 3I/ATLAS wasn't just unusual, it was rewriting assumptions about interstellar chemistry itself. In the weeks that followed, computational models ran day and night, simulating the pressure, temperature, and radiation conditions needed to form such a volatile, rich object. What emerged was a picture of a planetary nursery colder and darker than anything in our own system, a realm where sunlight was faint and carbon dioxide could freeze before water ever had the chance. The implications stretched far beyond comet science. If Atlas had formed in such an environment, then planetary systems like ours might not be the norm. the universe could be filled with worlds orbiting dim, red suns where ice giants and frozen debris dominate. Each one might be shedding fragments like this, pieces of frozen atmospheres and cores tossed out by gravitational tides, wandering through interstellar space for millions of years. Every one of them could carry the unique signature of its birth. Webb's detection was the first proof that these silent travelers exist in greater variety than we had ever imagined. In September, an interdisciplinary meeting at NASA's Goddard Center brought together astronomers, chemists, and even philosophers. They debated the deeper meaning of what Webb had captured. Some argued that 3I/ATLAS confirmed the universality of cosmic chemistry, that carbon, oxygen, and hydrogen dance to the same rules everywhere. Others saw something more poetic, evidence that the story of creation repeats itself endlessly across the stars, each world a variation on the same elemental theme. A few even speculated that the organic compounds within 3I/ATLAS could have been seeded by the debris of an ancient supernova, meaning that its atoms had lived through several generations of stars before arriving here. At the European Space Agency, engineers quietly began to model what a future intercept mission might look like. Using data from Webb's tracking, they plotted the comet's velocity relative to the Sun and realized it was already too late. No current propulsion system could catch it. But if another interstellar object entered the system within the next few decades, and if it were detected early enough, a small nuclear-powered probe could, in theory, reach it. Concepts like Project Lyra, once dismissed as science fiction, were pulled back onto the drawing board. Humanity, it seemed, was beginning to think not just about observing visitors from other stars, but about meeting them. Meanwhile, 3I/ATLAS continued its silent escape. Beyond Jupiter's orbit, its tail shrank into a thin wisp invisible to most instruments. The last ground-based detection came from the Subaru telescope in Hawaii, a faint point barely above the background noise. After that, it was gone, a ghost slipping through the outer solar system toward interstellar night. But scientists joked that Webb had given it a kind of immortality. As long as the data existed, ATLAS would never truly vanish. Public fascination, however, did not fade. Documentaries and podcasts revisited the story again and again. The lonely traveler from another world, the telescope that saw it, the image that proved our galaxy is full of connections we cannot see. In classrooms, children looked at the glowing red smear of the JWST photo and asked if they might ever visit the place it came from. Teachers had no answer, only the same wonder that had driven astronomers to chase a flicker of light across the cosmos. Months later, one final discovery emerged from Webb's archive. A subtle infrared reflection in the data hinted that part of 3I/ATLAS's surface was unusually smooth, as if coated by melted and refrozen ice. That suggested it might have passed close to its original star long ago, heated briefly before being hurled outward by a massive planet. The story of its birth, flight, and exile could be reconstructed from its very chemistry, a biography written in atoms. For the scientists who had spent years on this mission, the sense of closure was bittersweet. They would never see another image of ATLAS, but they had seen enough to change the narrative of our place in the universe. For centuries, humanity looked outward and saw emptiness between the stars. Now we know those spaces are alive with travelers, messengers carrying the raw material of life from one solar system to another. And perhaps, somewhere far ahead, in the cold between suns, 3I/ATLAS continues to drift. Its tail is gone, its gases frozen again into silence, but within its heart, the record of another world endures. A frozen memory of a dawn that shone around a different star. Webb's image captured it for a single instant, yet that moment was enough to remind us of something larger than discovery itself, that even in the emptiest parts of space, the universe is still telling its story. We just had to learn how to listen. As winter settled over the northern hemisphere, the story of 3I/ATLAS became part of the larger human narrative, not just a discovery, but a symbol. Late-night talk shows mentioned it between stories of politics and weather. Poets compared its path to a soul passing through the world. And philosophers wondered if perhaps our own planet, billions of years ago, had been seeded by such a traveler. The idea that life's ingredients could ride on icy messengers between stars no longer sounded like science fiction. It sounded like inevitability. Within NASA's data archives, the raw infrared frames remained stored like a time capsule. Future generations of astronomers will reanalyze them with instruments not yet invented, peeling back more secrets from that one cosmic moment in 2025. Maybe they'll find new isotopes, new organics, or even patterns hinting at processes still unknown. But even if they don't, Webb's first real image of 3I/ATLAS will endure as a turning point. The instant humanity proved that the galaxy is a shared ocean, not a collection of isolated islands. And somewhere out there, beyond the reach of any radio signal, that same comet still drifts, frozen, silent, unknowing that it changed us forever.